In this lesson, we're going to be solving log equations. So there's three different ways that we can solve a log equation depending on what is the equation that we are starting out with. So the first one we're going to look at is when you have only one log in the equation. So what we want to do here is isolate the logarithmic term, then we want to convert it to exponential form, then we'll solve for the variable, and then we want to check for extraneous solutions. This means that the argument cannot be negative. Now, the argument refers to the piece that's inside the parentheses that's right next to the log. So we should know that from when we went over graphing exponentials, that if we had, let's say, 3 to the x power, you're never going to get a negative number. The more positive numbers you put in, you're going to get larger numbers. The more negative numbers you put in, you're going to get fractions that approach 0, which is our horizontal asymptote. So we want to make sure that we understand that we cannot get a negative value, meaning the argument cannot be negative. So if we look at the example that we have here, we can see that log base 3 of 2x plus 1 equals 2. The log is already isolated, so we don't need to do anything there. So what we're going to do is to convert it to exponential form. So remember, that we convert it to exponential form by changing it. So we have 3 to the second power is equal to 2x plus 1. So 3 to the second power is just 9. So 9 equals 2x plus 1. If I go to solve for x, I'm going to subtract 1. So I get 8 equals 2x. And then to get x alone, we will divide both sides by 2. And we end up getting x is equal to 4. Now let's check to see if the argument is positive or negative. So unlike regular extraneous solutions, we don't really need to check if the left side and the right side equal each other. We're just checking the argument. So if we look at this, sorry, I should put in a 4 here in for x. Okay, so I don't really care about what this equals. I care about just the argument. So in here, I have 2 times 4, which is 8, plus 1, which is 9. Now, this is a positive number. Since it's a positive number, that means that x equals 4 is a good answer. So we're going to look at a few more examples like this. So if we look at this first one that we see here, we could convert it right from here. I'm going to just show the beginning of this, but not fully do it out. If we convert it and say that 3 to the 27th power is equal to 2 minus x to the 9th, 3 to the 27th power is a very large number. If we try to use our calculator, it's going to give us one of those scientific notation answers where there's an e in it, meaning 10 to the power of whatever. And then we'd have to take the 9th root in order to get rid of it. So instead of doing that, we want to remember our properties of logarithms from last class. So we know that we see an exponent here of 9. That means that the 9 can go down in front. So this will become 9 log base 3 of 2 minus x equals 27. Now the 9 is being multiplied to the log, so I'm going to get the log by itself by dividing by 9. So these 9s will cancel out. So we have log base 3 of 2 minus x is equal to 3. Now these are a lot easier numbers to work with. So now I'm going to go ahead and change forms, and I will make this into an exponential. So 3 to the third is equal to 2 minus x. 3 to the third is 27 equals 2 minus x. If I subtract 2 from both sides, I'm going to get that 25 is equal to negative x. So x is equal to negative 25. Now I'm going to check it against the argument, and I'm looking at the original equation. So I'm only going to look right here at the 2 minus x. If I plug in a negative 25, I get 2 minus a negative 25, which is really 2 plus 25. So that ends up being positive. So that is a good answer. Okay, and number 2 here, we see that we have a natural log. So we have an ln. Remember that an ln is the same thing as a log. The only difference is really that instead of log, we use ln. same difference. The base on an ln is e, so the ln, or the log, is already isolated, so we're going to change forms. So we're going to say that e to the second is equal to 5x, and then we want to get x alone, so we're going to divide by 5. Now, when you have an ln equation, you're going to get two answers. You're going to get an exact answer, which contains e, and an approximate answer, which we'll get by plugging in the calculator. So my exact answer is going to be e squared over 5. So I may ask for the exact or the approximate or both. So we want to make sure we understand where to find those. So the exact has e in it. If I plug this into the calculator, I'm going to get an approximate answer. And in this case, x is approximately 1.4778. Now, when you're getting the approximate answer, you want to have at least 2 decimal places or more. And this is our approximate answer. And again, if I plug them in, 1.44 times 5 is going to be a positive number, so we know that this is a good answer. Okay, so we're going to look at number 3 here. So notice that the log is not isolated, so we're going to add the 7 first. So we have ln of x minus 5. My goodness, nothing's working right now. Let me just fix this here. So ln of x minus 5, and that's equal to 1. Now that the log is isolated, we're going to switch forms. So again, the base is an e, so e to the first is equal to x minus 5. Well, e to the first is just e. So to get x alone, I'm going to add 5 to both sides. So I get my exact answer of x equals e plus 5. And then if I plug this into the calculator, I get an approximate answer of 7.7183. I notice the squiggly, that just means it's approximate, not equal to. Okay, and then on this one, number 4, the log is already isolated, so we're going to change forms. Okay, so we have e to the 4th is equal to x minus 1 over 2. I want to get rid of the 2 in the denominator, so I'm going to multiply both sides by 2. So these 2's will cancel out. So we have 2e to the 4th equals x minus 1. And then to get x alone, we will just add 1 to both sides. So x equals 2e to the 4th plus 1. That is our exact answer. And then again, if we plug this into the calculator, we're going to get an approximate answer of about 110.1963 as our approximate answer. So these are all examples where there was just one log in the equation. Now we're going to look at what happens when we have multiple logs, and we have to be dealing with the same base. So I'm going to say like 99% of the time, you're going to have the same base. So you don't really need to worry about the bases being different. So here are the steps that we're going to take when we have multiple logs. So you want to get all of the log terms together on one side of the equal sign and all non-log terms on the other side. So get all your logs together. Anything that's not a log goes on the other side. Then we're going to use the properties of logs to condense the logs into a single log. Once we have a single log, then this is very similar to what we just looked at, and we're going to convert it to exponential form, solve for our variable, and then we will check again for extraneous solutions, meaning that we're going to check to see if the argument is positive or negative. So the first thing we'll do here, noticing that the logs are already on the same side, so that's good. We're going to take these two logs and we're going to condense them. Now we see that there is addition happening, which remember from last class means that we're going to use multiplication. So I'm going to rewrite this as log base 2. I'm going to multiply the arguments. X times 3 is 3x, and that's equal to 4. So we've condensed it to a single log, and now that we have a single log, we're going to change forms. So we'll have 2 to the 4th equals 3x. Just going to go over here for more space. So 2 to the 4th is going to be 16. 16 is equal to 3x. I'm going to divide by 3. So x is equal to 16 over 3. Okay, if I plug 16 over 3 into my arguments, the only one I can plug it into is x. It's a positive number, so it is good. Okay, look at a couple other examples. So ln of 5 minus ln x equals -1. The logs are already together on the same side, so we're going to condense these. We can see that there's a subtraction sign, so we are going to change and make this division. So we're going to divide the 5 and the x, and then that's equal to -1. Now we'll change forms. So we have the base of e, so e to the -1 equals 5 over x. I'm going to multiply both sides by x. So this will cancel the x on the right. So I have x e to the -1 equals 5. And then to get x by itself, I'm going to divide by e to the -1. Now, if you remember, we don't like to have negative exponents. So if there's a negative exponent in the bottom, we can bring it to the top and it becomes positive. So this is just another way of saying 5e. Okay, so 5e is a positive. If I plug it in here, it's still a positive. That's my exact answer because it has an e in it. If I plug this into the calculator, I'm going to get an approximate answer of 13.5914. Okay, if we look at number 2 over here, the logs are not on the same side. So the first thing I'm going to do is bring the logs together. So I'm going to add this log to the other side. So I'm going to have log base 2 of x plus log base 2 of x minus 3, and that's going to be equal to 2. So I just moved this log to the other side. So now we have the logs together on one side, non-logs on the other side. We have addition, which means we're going to use multiplication. So we have log base 2 of x times x minus 3 equals 2. So I'm going to go ahead and distribute this x. So this will be x squared minus 3x, and that's equals to 2. So now I'm going to change forms because I have the single log. So we have 2 squared equals x squared minus 3x. 2 squared is 4. So what we should notice here is that this is a quadratic. In order to solve a quadratic, we need it to equal 0 first. So I'm going to subtract the 4 to the other side and set this equal to 0. So minus 4. And now I have to factor this. So what multiplies to -4 and adds to -3? We're going to use -4 and +1. Okay, I'm going to set these to 0. So I get 4 and -1. Now I need to check these. So again, I'm going to go to my original equation, and I'm only looking at the arguments. So the arguments are what's next to the log. So if I plug a 4 in, that argument is positive. If I plug a 4 in, this argument is positive. So 4 is a good answer. Now if I go to plug in -1, this is a negative, and this is a negative. Okay, it doesn't matter if both of them are negatives. If only one of them is negative, it is an extraneous solution. So x equals -1 is extraneous because it makes the argument negative. So our only answer here is x equals 4. Okay, a couple more examples of this type. So again, we do not have logs on the same side. So I'm going to subtract this log to the other side. So we have log base 2 of x minus 1 minus log base 2 of x minus 3 equals 3. I have subtraction, so I'm going to change this to division. So log base 2 of x minus 1 over x minus 3, and that's equal to 3. I have that single log now, so I'll change forms. So we're going to do 2 to the 3rd equals x minus 1 over x minus 3. 2 to the 3rd is 8. So I have this set up now. And I want to get rid of the x minus 3 in the bottom. I don't want to have a fraction. So what I'm going to do is multiply by x minus 3, which will cancel that out. And I also have to multiply by x minus 3 on the left. So I'm going to make sure I distribute that 8. So this is actually going to be 8x minus 24, and that's equal to x minus 1. I'm going to get my x's together, so subtract x. So I get 7x minus 24 equals negative 1. And then I'm going to add 24. I'm going to get x alone. I'm just going to put this over here, so I'll go whoop, like this, so I have more space. So I have 7x equals 23, and then I'm going to divide by 7. So x is equal to 23 over 7. Okay, and then this last one here, the logs are on the same side. There's a 2 in front of this log, which really means that it is an exponent. So I'm trying to condense this, so I want to have exponents where they belong. So this will be log base 6 of x squared plus log base 6 of x squared plus 5 equals 1. Because I'm adding, I'm going to change this to multiplication. So I have log base 6 of x squared times x squared plus 5 equals 1. I'm going to distribute this x squared. So I'm going to get x to the 4th plus 5x squared equals 1. I'm going to switch forms. So 6 to the 1st equals x to the 4th plus 5x squared. 6 to the 1st is just 6. Now this should look familiar to you. This is a quartic function because our highest exponent is a 4. When we were working with polynomials and we were factoring polynomials, this is the one that is treat like a quadratic. So I want this to be set to 0, just like a quadratic. So I'm going to subtract the 6 over. So x to the 4th plus 5x squared minus 6 equals 0. When it's like a quadratic, we have the exponents of 4 to nothing. So we know this is like a quadratic. So if this was a quadratic, we would factor normal, but instead of using x, we're going to use x squared. So what multiplies to negative 6 that adds to 5 is going to be 6 and negative 1. So we're going to use x squared plus 6 and x squared minus 1. Now looking at these, because these are both quadratics, we want to see if we can factor any further. We notice that this one is a difference of squares. So the first one is not because it's not a difference and 6 is not a perfect square. So we'll leave that as x squared plus 6. X squared minus 1 will factor into x plus 1, x minus 1. So when I go to solve these, x squared plus 6, if I solve that, I'm just going to do this over here real quick. X squared plus 6 equals 0. We get x squared equals negative 6. When we take the square root of a negative, we have to pull out the I. So we're going to get plus or minus I square root 6. If I set x plus 1 to 0, I get negative 1. X minus 1, I get positive 1. Now, since the exponent is a 4, there should be 4 answers. We have 2 here from that plus or minus, and then these other 2. Now we have to check them for extraneous solutions. So again, we're going to go to the original equation. I can't plug in an imaginary number because it's not real. So these are extraneous. If I plug in a negative 1, I can see that this is going to be a negative 1 argument. So that is also extraneous. If I plug in positive 1, that is a positive. This is also a positive. So this is the only answer that we can use. The last type of equation that we'll see is if all of the terms have logs in them. So every term has a log with the same base. So what we're going to do is condense the log expressions on each side of the equal sign by using our properties of logs. Because the logs will be on both sides and have the same base, we can cancel out the logs and just set the arguments equal to each other. And then we're going to solve for the variable and then check for extraneous solutions. So here we have our goal basically is to do this, get one log on one side, one log on the other side. So we have a log, a base 2, a log base 2, they're the same. So we're just going to take the arguments and set them equal. So 2x equals 100, divide by 2, x equals 50. If I plug 50 in, I get a positive argument, so this is a good answer. Now, technically, if you wanted to subtract the log base 2 of 100 to the other side and set it to 0, and then condense the left and then change forms, you'd have 2 to the 0 power equals a fraction, and then when you solve, you'll end up with the same answer. It's a lot easier just to kind of cancel out those logs. So we'll just look at a few more examples of this. Okay, so number 1, okay, everything has a log. They all have the same base, which is 10. So we're going to condense the left-hand side. We have subtraction, so we're going to change this to division. And now that we have a log equals a log, we're going to take those arguments and set them equal. So x over 5 equals x plus 1. I'm going to get rid of the 5 in the denominator by multiplying by 5. When I multiply it by 5 on the right, I want to make sure to distribute that 5. So x equals 5x plus 5. I'm going to subtract 5x. So I get negative 4x equals 5. I'll divide both sides by negative 4. So x is equal to negative 5 over 4. Now I'm going to look at those arguments again. So x and x plus 1. If I plug in negative 5/4 here, this is going to give me a negative argument. If I plug in negative 5/4 here, this will also give me a negative argument. So since this is negative, okay, that is an extraneous solution. Since there is no other solution to choose from, the answer to this is no solution. Okay, number 2, here we have an ln, same thing as a log. Looking at the left-hand side, we're going to condense it. We have addition, so we're going to change it to multiplication. So ln of 3x equals ln of 7x minus 24. They have the same base, they're both e's, so we're going to take the arguments and set them equal. 3x equals 7x minus 24. Subtract 7x. So negative 4x equals negative 24. Divide by negative 4. X is equal to 6. I go check my arguments. If I plug a 6 here, it's positive. If I plug a 6 here, this whole value is positive. So that is a good answer. Okay, last couple we're going to look at here. So if we have, I'm just going to change my size of my pen. Again, we're going to condense the right-hand side this time. So we have log of x plus 5 equals, this will become log of x minus 1 over x plus 1. Because we're subtracting, so it changes to division. They both have the same base, so we can take those arguments and set them equal. So I want to get rid of the x plus 1 in the bottom. So I'm going to multiply by x plus 1 in order to cancel it on the right, which means I also have to multiply it by x plus 1 on the left. So I need to FOIL the left-hand side. So I get x squared plus 6x plus 5 equals x minus 1. We see that quadratic, that square here, so we want to make sure that we set it equal to 0. So I'm going to subtract the x and add the 1. Subtract the x, add the 1. So we end up here with x squared plus 5x plus 6 is equal to 0. So now we have to factor this. Multiplies to 6 and adds to 5. So we're going to use x plus 3 and x plus 2. Set it to 0. So if I set x plus 3 to 0, I get negative 3. X plus 2, set it to 0, I get negative 2. We need to check our arguments. So if I take the negative 3 and I plug it in, negative 3 plus 5, that is a positive, so that's okay. Negative 3 minus 1, that is a negative. Negative 3 plus 1, that is a negative. So if any of them is negative, it's an extraneous solution. So we see that that doesn't work. Okay, so let's check it with 2 or negative 2. So if I plug in negative 2, negative 2 plus 5 is a positive, negative 2 minus 1, negative 2 plus 1. So both of these give me a negative answer. So this is also an extraneous solution. Because there's no solution to choose from, this answer would be no solution. Okay, and then this last one here, let's change that. So we have to condense the left-hand side. We have subtraction, so we're going to make this division. So 6x over 4 minus x equals log of 3. Logs have the same base, so we're going to set the arguments equal to each other. So 6x over 4 minus x equals 3. I want to get rid of 4 minus x, so I'm going to multiply by 4 minus x to cancel it. I'm going to also multiply it on this side. Make sure we distribute that 3. So I'll go over here. So we have 6x equals 12 minus 3x. I'm going to add 3x to bring my x's on the same side. So 9x equals 12. Divide by 9. So x equals 12 over 9, which reduces to 4 over 3. If I check that, 4 over 3 is a positive here, 4 over 3 is a positive here, and there's nothing to plug it into the last one. So our answer would just be 4 over 3.